Good afternoon, everybody. My name's Chris, and welcome to the June edition of the AESIN Tech Talk. Just whilst everyone arrives, I'm going to tell you a bit, well, actually quite a lot, actually, about the upcoming AESIN 2024 conference in Gaydon on Thursday, the 11th of July at the British Motor Museum. This year's theme is collaboration in a technology-rich era, and we've got over 25 speakers confirmed, over 20 exhibitors, and an absolute stack of stuff going on. Now, I could spend the next 30 minutes talking about the conference, but it's actually easier if you just go to aesin.org.uk/conference and see for yourself just how much stuff is in store. This conference is unmissable. And if you go online, you'll probably agree. In fact, you definitely will agree. It's aesin.org.uk/conference. Right, let's get the Tech Talk started. And it's my pleasure to introduce today Stewart Edmunson. Stu is today going to be giving us an update on the current skills landscape, and we'll catch up on the work of the UKESF, that's the Electronic Skills Foundation. Stu has been the UKESF CEO since 2015. He has a degree in electronics and a wide range of engineering management experience in both public and private sectors. He has been a chartered engineer for over 20 years and is a fellow of the IET. He is a Royal Academy of Engineering visiting professor and employability and ethics at Aston University. And today he joins us from Shropshire in the West Midlands. Stu, the floor is yours, my friend.
Chris, thank you very much for the introduction. Hello, good afternoon. Welcome everyone. Let me share my screen, and then I'm going to talk about. I've got a presentation for about 20 minutes, and then I'll come out of that. I'll summarize, and then perhaps we'll have a discussion, and we can talk about any questions and do it that way. So let me share my screen. I think that's come up. Chris, can you just confirm?
Yes, it has. You're good to go.
Okay, well, let me begin then. Let me start by talking a little bit about our organisation. We were founded in 2010, so next year is our 15th anniversary. And our claim is that we're the only organisation solely focused on electronics in the UK in terms of STEM outreach and engagement. We've got a diagram that shows what we're doing, and we're trying to tackle the skills challenge in our industry. And we define skills challenge with two dimensions, both shortages and gaps. So at school, starting at the bottom left, we're trying to encourage more young people to study electronics, and I explain some of our activities and how you might potentially collaborate and potentially support those as we go through. At university, the main thing that we do is connect students with employers through our scholarship scheme. And that's a photo of me and the cohort from last year at our residential week at York, where we give them a week of developmental activity. And third and final thing that we do, or our third and final priority, is around skills advocacy. And that's a recent photograph of me at number 10 as part of the semiconductor panel 1 year anniversary of the strategy, discussing the way forward on that. So in terms of the strategy, that's a good place to start. The semiconductor strategy for the UK was published last May, so just about 13 months ago. Now, you could say, and I would agree, it was much needed and long awaited. Whether it's fit for purpose, whether it's enough, is something we could debate later, and everyone's got their own opinion about. What I particularly, from our parochial point of view, was really pleased to see this section on skills and talent, and it's our emphasis by putting a couple of sentences in bold there. So they say the approach to skills, the government say the approach to skills, two parts: investing in schools and teachers and promoting industry-led learning to ensure that pipeline. And that's a real key in terms of skills. There's no quick fixes. It does take effectively a generation, an educational generation, and it is building that pipeline, which is what we're all about. So we're really pleased to see that as a strategy, in the strategy. So has the government delivered on their rhetoric? To a certain extent, for sure, yes. You may have seen, you may already be aware, they have funded 2 innovation and knowledge centres in the last 12 months, starting one at Southampton and one at Bristol. They've also supported some research, and this has been led a consortium of 4 universities, led by Themis at Edinburgh University, looking at how AI tools could help with the improving the efficiency of developing semiconductor design and also verification. As far as we're concerned, Innovate UK supported 11 skills-related projects to the tune of almost £5 million, and we were the welcome recipient of some funding for that, for 2 projects. The one that's shown there, which is in conjunction with the CSA Catapult, trying to engage people in Wales through supporting 40 schools, a number of face-to-face events, and some financial support for students who are going on to university in September. Really pleased to say that project has been really successful. We did at the start wonder whether we'd get 40 secondary schools in Wales committed to the programme. We've been oversubscribed, which is great. They've received all their resources and we've started to engage their teachers. We've held 3 events at Trinity St David, Bangor University, and also at Swansea University, and we've got some other events planned for the next few weeks and into the autumn term. And for the students, we had a range of really deserving and very capable pupils who are leaving college or in year 13 of school, all going on to study electronics, engineering, or a related subject at university, who are looking for our support. So that's a really good example of a programme that we've been able to deliver with the government's help as a result of the semiconductor strategy. So to summarise what we're doing in terms of schools, our classroom resources, which I mentioned briefly, we've reached over 700 schools. If you look at the number of schools in the UK that deliver A-levels, our resources are focused on A-levels, physics and computer science. There's around about 3,000, so we're at over 20% of those schools. On the back of what we've done with Wales, we've adapted one of our projects to become a Crest Award. I don't know if people are aware of Crest Awards. They're organised by the British Science Association. They're a bit like Duke of Edinburgh's awards, but focused on science. And we've got a silver level, which is designed for 16-year-olds, 17-year-olds in electronics, which is now available through the British Science Association Crest website. We've got a significant strategic focus on addressing the gender balance to make our sector more inclusive and address that gender imbalance. And last year, over 400 girls participated in our Girls in Electronics events, and I'll say a little bit about those in a moment. And as I said, we've got this bespoke programme from Wales to focus on, bespoke programme in Wales with support from Innovate UK called Spark the Imagination. So that's what we've done and are doing. What would we like to do in the future? Well, we believe the bespoke programme that we're delivering in Wales could be replicated in other regions, be it the West Midlands, the North East, or Scotland. And we're exploring both public and non-public ways of trying to fund that, using Wales as a proof of concept and the success we've had there. I said a lot of our projects are focused on secondary schools and particularly sixth form, but we recognise that young people make choices and start thinking about careers much sooner. So we've developed a proof of concept, a prototype of a project for primary schools. And in the next school year, we're looking to scale that up and implement that in a number of primary schools. There's a lot of evidence I saw a report from somebody at Northumbria University that said children start getting an idea of a career or what they're interested in about 8 or 9. So it's really important that we raise the profile of electronics and semiconductors in primary schools. It's not an easy thing to do because you've got to have the right project, and you've definitely got to work with teachers because there's an awful lot of primary schools and teachers are the key influencer for children that young. So that's something that we're looking to pursue in the next academic year and onwards. I talked about the classroom resources, and we supported over 700 schools. Those are the sets of resources. They aren't projects per se. They are resources to help teachers deliver the curriculum in an engaging and hands-on way. Most of us as engineers learn in that kinesthetic way. We like to learn by doing, and our resources enabled us to do that. Teachers, we get really good feedback, and importantly, that reaction from pupils to understand, well, what is electronics? Here's an example, here's some things to learn, has been very positive. It's also linked to attainment, and that's one of the big selling points when we're talking to schools. Although when I say selling points, we give the resources free to schools, they're not sold to schools, is that they help raise attainment, and they are linked to the curriculum. So it not as a byproduct, as a core part of our product, as our project, is that we're hoping to raise attainment as well as generate interest in electronics. They are available to schools. So if you've got schools that you as a company are working with or have links with, then we're very happy to see how we could support those particular schools if they're not already involved in our program. I mentioned Girls into Electronics, and this is a slide taken from the event that we hosted at King's College London. In the event, which is non-residential, I think that's really important to be non-residential. Residential courses are a potential barrier to certain participants. We invite pupils to come along, bring their teachers, so teachers can bring class groups along, and they're designed for girls 15 to 17, so those doing GCSEs or first year or post 16 study. And essentially it's to answer three questions. A little bit, what is electronics, to explain, and you can see there we use our resource, which is an Arduino-based kit that allows people to achieve something really quickly as a hands-on session. It's important for those that haven't been to university or don't have family members at university to see what it's like. And we know from our own research that 20% of people who go onto our scholarship scheme are first in family to go to university. So what's it like to study at university? And it's interesting when I've been to some of these events to actually walk around a university and look at it through a young person's eyes. We become maybe blasé as adults looking around a university, but it's really interesting to see it through a young person's eyes about the facilities and just the general what's it like to be at university. And we make sure all the speakers, as far as possible at this event, are female. So female students, female lecturers, female researchers, and also female engineers sharing what it's like to work as an engineer, designer in the electronics sector. The feedback from last year was really positive, as you can see there. We had over 400 girls participate. And this year, we're in the middle of our 2024 program. We're partnering with 12 of our universities that are hosting our events. Strathclyde and Heriot Watt have had their events. Queen's Belfast are hosting one this Friday. And then we move down into England with 9 events over the last part of this month and the beginning of July before the term ends. Just worth taking a step back and explaining a little bit about why we are focusing on the gender imbalance, which I'm sure you'll recognize from your own companies and your own experiences that there is a massive gender imbalance. And I wanted to share this data. It's a couple of years old, but it is taken from the Engineering UK. And it's about the number of students and the makeup of undergraduate cohorts. And I'll just pull out this for you, that overall, more than at university, in higher education, more than half the students, 56.5% it says there, are female. If you look at engineering as a whole, then it's under 20%, 18.5%. However, for electrical and electronic engineering, it's as low as 13.5%. And that's a challenge that we're facing. That if you as employers are looking to be as inclusive as possible and to promote diversity within your staff, actually we need to think about universities and all the way back to schools, which is why we have this specific intervention, Girls into Electronics, to try and make a difference. Is our work making a difference? Well, it is always difficult to take, and it does take a long time to change. However, last year, we know that more than a quarter, 28% of scholarships that we awarded to our undergraduates went to female students. Now, bearing in mind what I've just said on the previous slide, that it's 13.5% average across the UK, I think that is showing real progress and something we're very proud of. And I use this sort of photo just to show, which is last year's scholars at the residential week in York. Just when you see the photo like that, that they are a very diverse bunch, which is fantastic to see. I mentioned our scholarship scheme, and that's a key part of our work at the foundation. The way to sum it up is it's a wraparound program to augment the university studies of undergraduates. And the idea is that when they graduate, that they will be, if you like, more work ready. They'll have had some work experience through one of the companies that join our scheme, as well as development activities, and as well as showing an interest in electronics and helping others through our outreach and schools engagement event. And as it said there, it is considered a best-in-class scheme, and we were honoured to win a Princess Royal Training Award in 2022. We partner with 28 leading universities right across the UK, so it is students from all those universities are eligible to apply. The third area of our work is around supporting industry. We are, as I said, a part of the wider semiconductor advisory panel, a specific group on skills, which is great to see. We've also led the development of 2 apprenticeship standards, one at level 6, which has a lot of attraction and has been used reasonably extensively by a range of employers and is offered by a number of universities across England. We do, and we are looking at a number of things and ongoing work shown in red there. We are looking at what we can do to augment and add to chip design. Some universities cover the theory, the knowledge and understanding around digital, particularly chip design, high-level languages and so on, and an element of chip design, but it's actually very few. Even fewer actually cover the know-how, how to use the tools and how to do chip design. So we developed a proposal and we're seeking funding initially through the government to try and do that, and that's in partnership with STFC using Europractice. We also recognise that a lot of graduates do study physics. More people study physics than electrical and electronic engineering. We'd class that as an adjacent subject, and maybe there's a scope for a postgraduate conversion. That's to say, taking physics graduates, giving them a combination of some knowledge of understanding about semiconductors, some know-how and some work experience in order that they pursue careers in our sector. It's an idea, a concept at the moment, and we're talking with the Institute of Physics about how that might work. So it's not a firm idea, it's a conversation and a discussion at the moment. Interesting enough though, the Institute of Physics, they do recognise that semiconductors is one of the, I think their expression is physics-enabled spheres, and it's part of their 5-year strategy to try and support semiconductors more and make that link between physics and semiconductors more overt. In terms of skills studies and work, we've got two areas on the go. We're just about to publish a report that we've done based on some research about work readiness. The question is, and it's a relatively simple question, are graduates fit for purpose in inverted commas? There's a whole lot of reports that I've seen. One that comes to mind from the IET that said the majority, and I think it was just a majority of employers actually thought engineering graduates weren't fit for purpose. So we've gone under the bonnet on that a bit, spoken both to hiring managers, looked at their expectations, and also looked at the experience of recent graduates, and this is in electronics, our area, and we're about to publish a report on that. The other area that we're currently looking at is technician skills. It's not an area that we've looked at much in the past, but it's really important, and that's particularly around semiconductor manufacturing. And the project we're working with is with a company called Paragraph. They're based over in Cambridgeshire. They're using graphene layer on silicon for a very innovative semiconductor product. However, as they scale up their manufacturing, and this is recognized by a number of different companies that we talk to, there's a challenge in terms of getting enough technicians with the right skills in terms of process operators, technicians that both support the process and maintain the equipment, and those process engineers. And fundamentally, there are no national occupational standards, and as a result, there's no, in England there's no apprenticeship standards. Therefore, this is a real gap. What we're going to do is undertake a bit of a study with Paragraph as a case study, look at the current landscape, look at their needs, and then out of that, develop a proof of concept course, which we then see could lead on to some wider work across the sector around standards in terms of occupational standards and apprenticeship standards, which, as you will probably know, without an apprenticeship standard, you can't develop an apprenticeship program and can't employ apprentices and can't gain the benefit from that. So the starting point is apprenticeship standards, which is what we're looking at in that area. I think that was the last slide, and that's got my email address on. I'll share that with you, but let me stop sharing and just sum up and make a couple of points. So how you might wish to engage, or how you could engage, or how we'd like you to engage, there's a number of things. So if you would like to support our work with schools, and you think that's worthwhile, and if you've got schools in your area that you currently engage with or would like to engage with, then perhaps we could talk about that, either through a charitable donation or your CSR policy or your outreach. It'd be great to support more schools. Having seen our program, a summary of our program, you might think you've got a specific idea. Maybe something specifically around automotive sector would be fantastic. So we're always open for possible collaboration and discussion about ideas. That would be something really good. So if you've got some ideas or something that you're already doing or you think you might like to do around schools engagement, that would be great to talk to you about that. Our scholarship scheme is a great way of connecting with students. I'm sure a lot of companies, a lot of people on the call here today are looking to recruit graduates. Recruiting graduates is time consuming, it's potentially risky, as in, are they going to work out for you? The solution, or a solution, and a way of de-risking that, is to get students in for work placements during the summer. Again, it's quite hard to organise by yourself. We can take all that away with you and connect you some really good quality undergraduates from our partner universities. Again, contact me if that's of interest. More broadly, if you might having heard what we're talking about in terms of technician skills and apprenticeships and so on, you might have some ideas of your own about workforce development that as a group, as AESIN, you might want to take forward. We're always available to support, advise, to help with consultations. Maybe there's scope for specific apprenticeship standards in the automotive electronic space, or maybe some other interventions that could come under the AESIN banner that you've spoken about in your meetings and discussions with Gunny. So that's always good to do, and we have got that support there. So that's really my end of my pitch. So I'm happy to take it up for any questions and a discussion. Back to you, I think, Chris.
Thank you very much, Stu. We'll get the Q&A underway in just a few moments. If you're watching this live, if you have a question or comment for Stu, put it in the Zoom chat facility. Don't raise your hand, just type it out in the Zoom chat facility and I'll ask away. Just before we do get the Q&A section underway, our Tech Talk guest next month will be Dr. Roger Rivet, who is a Programme Fellow on the University of York Assuring Autonomy International Programme, and he is a member of the MISRA Automotive Safety Argument Working Group. He is an independent functional safety specialist, and he'll be with us on Wednesday, 17th of July at 12 p.m. BST. If you're watching this broadcast live, You can register. The link to register is in the Zoom chat facility right now, or if you're watching the recording of this Tech Talk today, go to aesin.org.uk and go to the events section and you can get yourself registered there. By the way, you may see the July Tech Talk build has been with Andrew Patterson of Silvaco, but Andrew has had to reschedule. So that's why we now have Roger Rivet. So make sure and join us for that. As I say, Wednesday, the 17th of July is the next AESIN Tech Talk. So to the Q&A. And as is customary, I will get things started. I can see plenty of questions coming in on the Zoom chat facility. But Stu, do you think the change of government or the expected change of government, I should say, at Westminster, will affect support for semiconductors?
So the government have committed, the old government, current, are they still the government? I think they are still the government, aren't they? We'll say the current government. It was long awaited. You know, people said that the strategy they published was 2 years too late, and I tend to agree. But it was great that they talked about that. More broadly, they identified semiconductors as one of the 5 enabling critical technologies that were going to support the country's aspiration to be a science superpower. Again, science superpower is a bit of rhetoric, but the 5 technologies were AI, quantum, future telecoms, semiconductors, and life sciences. So of 3 of those, aside from semiconductors, are definitely underpinned, and semiconductors is fundamental to that. So and why is that? That's because technology is the future. It's a key to improving people's lives and the key to growing the economy. And those areas of economy in terms of quantum computing, using AI to improve productivity, and future telecoms are seen as growth areas. So the answer is, I don't see that it will change. I see that any incoming government would recognize the importance of semiconductors and continue on the same way. Maybe the benefit would be that they would invest more actual funding. And if you look at what's been happening in America and Europe, there's a whole lot of wider initiatives, particularly on skills development, that both America and Europeans are progressing with. So I hope it's going to, I don't think it will change, but it may get better. We have engaged the government directly, and also through the Department of Science, Innovation, Technology. So those civil servants and the teams are likely to stay. We've also engaged shadow ministers as well. So they are aware of our work, the importance of skills, and that argument about skills are an enabler of a sector that's going to grow and support the economy. So that's something to I'm reasonably optimistic about.
All right, thanks for that, Stu. Hardeep asks, being around for 15 years is a great achievement. Have you noticed any differences in the graduates over the years? This is more to do with hiring managers saying graduates are not quite fit for purpose, in quotations. Has this been the case for a long time, or is it a recent development? That's from Hardeep.
Oh, thanks, Hardeep. I'll start with a story, an anecdote, if you will. You saw the photo of our current cohort of students, very diverse. If I go back to the very beginning, our first cohort, and we started very small, 5 universities, 6 companies, 12 students, they were all white males. So I think that's a big change, and I'm really proud. You know, it's something we work on to improve that diversity. So that's something. So thank you for saying it's a great achievement. We have grown with the support of industry, and it's a symbiotic relationship. We can only operate with the support of industry, but we are there to support industry and employers. So that works really well. Hiring manager, I did tease you, didn't I, with our study? And I'll spoiler alert. The research that we found is actually the problem isn't as acute in our sector of electronics. There are definitely specific challenges, and one of the misconceptions, if you like, is around education and training. Universities provide education, higher education, therefore the theoretical knowledge and understanding and the principles, as well as some practice. The know-how, the specific training, for instance, in using EDA tools to design chips, is not what university is about. So there will always be a gap. However, hiring managers, and you all know this, and you build that into your expectations. Generally, we found that graduates are curious, they're interested, they're motivated, and that they do have that ability to think for themselves and work independently. So I would say the gap isn't as much as the headline figure for across engineering, which is good for our sector. There are some specific knowledge and training gaps that need to be addressed, and there's lots of ways through internal programs or commercial courses or just learning on the job that they can be addressed. But I actually think current graduates are really very able, highly motivated, and are good.
Stu, natural interest, me being in Edinburgh right now, you
Yeah.
talked about interventions. Does your work cover Scotland and Wales and Northern Ireland?
We try to. We've got 4 universities in Scotland, 2 in Wales and 1 in Northern Ireland as partners. So students from those courses are eligible to be part of our scheme. We work with companies in all those areas, and we have supported schools. It is harder getting into schools in those areas because we can't do it directly, and that's why I'm keen. Have been keen for the program that we're delivering in Wales to get into Wales, and would love to do the same in Scotland. In terms of skills policy, they are devolved policies. So things like apprenticeships are different in Wales and in Scotland. And when I talk about apprenticeship standards, that is just for England. You need to look at different. It's different in Scotland and Wales. And in fact, in terms of semiconductors, Wales do have standards and apprenticeship programs, and I know there's opportunities in Scotland as well, principally through degree apprenticeships. Heriot-Watt are one of the providers as well. So it is different. We do cover the UK. It's in our title. We'd like to do more, and it's just working out how to do that.
All right, thank you. I think we've got time for one more. I want to get this in. Could you talk a bit more about apprenticeships?
Yeah, of course. If we go back, just to say that any employer with a pay bill, and this is England, a wage bill over £3 million pays something called the apprenticeship levy. That's 0.5% of that wage bill goes to goes into a pot, which can only be spent on apprenticeship programs, which was an outcome of a couple of reviews about 10 years ago, trying to incentivize companies to support more work-based learning. Work-based learning has been around for millennium, and in engineering, it's a great way because, as we just said, just having the knowledge and understanding of engineering per se doesn't make you an engineer. You do need to develop that practice. So apprenticeships are really good. Numbers have been declining. There is an element of bureaucracy around the apprenticeship levy, and one of the challenges is you need to develop apprenticeship standards, which then training providers, universities, colleges can develop into programs, and people can recruit staff to go on those programs and go through an apprenticeship. So they get the benefit of the learning as an individual, and the company gets the benefit of developing the skills, competences, and capabilities of staff. The problem is, and when I look across the automotive electronics space, there aren't those apprenticeship standards. So it makes it problematic for companies to fully exploit. They have to pick apprenticeship programs based on standards that are perhaps more generic. There's one at technician level called engineering technician, and one at graduate level, which is called, well, a postgraduate level called postgraduate engineer. So my plea, not plea, but observation, if you will, and offer is that perhaps AESIN as an organization to come together, and the members would look at developing those apprenticeship standards, which will enable companies to get more involved with apprenticeships.
Stu, we've got a live audience of 52 people watching at the moment. Either you've explained yourself incredibly well, or everybody's been shy with the questions today. But thank you very, very much for your time today and for your presentation. Before we get going, at the top of today's broadcast, I was saying a little bit about the 2024 AESIN conference, which is taking place on Thursday, the 11th of July. Just to repeat, it's going to be at the British Motor Museum in Gaydon, and you can register for that now. If you go to aesin.org.uk/conference. We've got over 25 speakers confirmed, over 20 exhibitors, and just so much stuff going on. The agenda for this fantastic day is available, like I say, aesin.org.uk/conference. And as I mentioned previously as well, we're going to have Dr. Roger Rivett as our special guest for the Tech Talk in July. So that wraps it up for today. All that's left to be said is good luck to Scotland against Switzerland tonight. I don't know, Stuart.
Yeah, I'm keeping my fingers crossed. It was I found it painful watching, even as Englishman. I found it painful. So good luck to Scotland tonight. Good luck to England tomorrow. And just say I will be at the AESIN conference on the 11th. So if anyone wants to talk to me, then it'd be great to have a chat about things then.
What's your score prediction for tonight, Stu?
Well, hopefully a Scotland win.
Yes. Okay. All right. I will take that. I will take that. I'm going to go for an early Scotland goal, parking the bus for the rest of the game. Very, very stuffy and anti-football. So we'll see what happens. Thank you very much for your time today, Stuart.
You're welcome.
I'll
Thanks,
see
Chris.
you at the conference, and great to see you again. All right, we will see you again next month when, as I say, we'll have Dr. Roger Rivett. But that's all for today. Thank you very much for joining us. And if you've joined us late, you will be able to view the recording of today's broadcast. We'll see you again next time.